Oh, uh, we have a problem. And it's that our WebAssign is asking us, um, how much, what's at what speed would the Pinecone have landed if there had been no air resistance? Well, I guess it's giving us that there's a pinecone that fell with air resistance at 11 meters per second and height of 15.9 and the mass what mass was 0.23. Well, let's disregard part B for now and let's just focus on part A real quick. So we have our pine cone. Um, I guess that looks similar to a pine cone, but it'll do. So pine cone is dropped down like that, and this is 15.9 meters. Well, before we do anything with this, I just wanna uh, see how much work was required by us to lift this up here by 15.9 meters. Well, pinecone weighs 0.23. Or let's draw this really quickly. So we have mg, and that's gonna be force. That's gonna be the force. And to counter this, or to make the acceleration constant, we must have an upward force that is equal to mg. So that is going to equal to mg is 0.23 times gravity, which is 9.8. So what is that? Well, let's see. So 0.23 times 9. Oh crap. 1 second. So 0.23 times 9.8. And that's equal to 2.254. So 2.254 is our force. That is our force. Newtons. So this is Newton. Is our force that is required for us to at least exert on this thing to have it moving at a constant velocity. So how much work do we have to expend in order to move it off 15.9 meters? Well, it's gonna be we can use the equation work equals force times distance. So force is this, that times distance is 15.9, so that times 15.9 is going to equal to work, which turns out to be that times 15.9 is 35.8, so it turns out to be 35.8 joules. Alright? Okay, so what did we just do? Well, we did mg times distance, so they actually have a name for that. And when you go up here, this is also known as potential energy. And more specifically, gravitational potential energy. And that's equal to mass times gravity times height. So let me write this in. So mass times gravity times height. Now, what happens when this thing goes on the ground? Well, potential energy is 0 because height is 0, so everything else is 0. So what concept does this bring us? Well, if this gets to down here, then energy must go somewhere, because of the law of conservation of energy. But where does all that energy go to? Well, the energy goes to, so when the pine cone's down here, so the pine cone just fell, when down here, when it goes down, then the energy goes to the kinetic energy. So kinetic, it transforms itself into kinetic energy. And what is kinetic energy? Well, it's 1/2 mv squared. Okay, so if all of this transforms into kinetic energy, and since our potential energy is 35.8 joules, we can say that 35.8 joules is equal to the kinetic energy when it's at the bottom. So 35.8 is equal to 1/2 mv squared. And now we just solve for v, and when we solve for v, we get 17.65. So let's do that real quick on the calculator to make sure. So it's gonna be 30. Why did I just clear that? Well, 35.8 times 2. So you multiply by 2 on each side to get rid of that fraction. And then you divide it by the mass. That's 0.23. And then you square root that. So you get 17.6. Close enough. So 17.6 around there. Meters per second. So that would be my answer. That would be my answer. And you would have a different answer because you have different values. And part B says, did air resistance do positive, negative, or zero work on the Pinecone? Well, Pinecone is moving this way, but it's slowed down, which means the force of air resistance was going this way, which means the force was acting on a different direction, the opposite direction of the motion, which means the work was negative. So that's basically what this problem is all about.